Hey everyone, this is lesson 10.2.3 on chords and angles. This is a continuation of the different relationships we're looking at within circles. The last time, or the last pair of notes that we went over, we introduced a couple of new terms or relationships. One of the latest ones that we talked about was this idea of an inscribed angle, where it's an angle that has the vertex on the circle, and we compare that to a central angle where the angle or the vertex is at the center of the circle. Now, when these two angles share the intercepted arc, which in this case would be arc AD, when they share the same arc, there's a special relationship that says the inscribed angle, the smaller angle, even though it looks bigger because it's longer, the smaller angle is actually half of the measure of the central angle. So in this case, it looks a little bit more open, and this one looks a little bit more closed. So that's a special relationship you need to know. And then some other terms that were mentioned, this idea of a chord, where the endpoints of this segment are on the circle. And then major arc, minor being smaller arc versus major being the larger of the two arcs that complete the full circle. In this case, major arc, don't forget we use 3 letters to indicate direction. To go from A to D to B would tell us we're going basically the long way around the circle, versus a minor arc would be the shortest distance from A to B. All right, so that's a quick reminder review of some prior topics. It's up to you if you want to recopy that down or not, but we will be using this information in today's notes. So if you need to recopy it just to have it on that same page, that might be a good idea. Else, if you have prior notes close by, then maybe you could just use those as well. All right, so in this problem, there's a few steps to this one here. There's going to be, this is the whole problem. I'm going to focus in on the top part, A, B, and C. Here we have a circle with a few points on the circle given to us. Q, P, and R are given to us on the circle. What we want to know, first question is, what's the measure of an angle inscribed in a semicircle? Right? It's a question, but it's actually kind of like a title as well. Like, that's really what we're trying to focus on. So if you're not familiar with the term semicircle, hopefully you know what a circle is. So semi would really just means like half of a circle. So a full circle is 360 degrees, and so our semicircle, which looks like a semicircle, that's going to be 180 degrees, which we should be already familiar with. All right, so that's why I have here, it's a 180 degree arc. All right, so now that we've kind of reviewed that, first question for you is, what is the measurement of angle P in this diagram? So angle P would be this angle here, right? We're looking at this. I want to know if you know what the measurement of this is. Well, you might say, well, there's no other numbers here. This is confusing. Well, let's go back to the idea of a semicircle is 180 degrees. So I've already highlighted this for us. So from Q to R, that is our semicircle. So this is going to be 180 degrees from Q to R. So I'm going to write, this is 180 degrees right here. All right, so if I know this measurement is 180 degrees, the question is, what is the measurement of this angle? keep in mind, you have to think, is this an inscribed angle or is this a central angle? Which, as a reminder, right, look at the notes above. That's why I mentioned this. Inscribed angle is half the measure of the central angle, which, don't forget, central angle and the arc are always the same measurement. So let's see if you get this correct. What is the measurement of angle P? All right, see if you got this correct. So since this is an inscribed angle and it's half of the central angle, well, central angle is going to go from here to here. It actually looks very open. This is also going to be 180, which means this angle here is going to be 90 degrees. All right, so this is going to be 90. Hopefully you got that correct. All right, second part, QR, segment QR is I'm looking for a word here, a vocab word that you might know. So QR, notice this is a segment QR. There is no segment QR in this picture. So if we actually add the line from Q to R, let me add from Q to R, right, from Q to R, what is the name of that? What do we call that? All right, so if you don't know, there's actually two possible answers. I won't prompt you for this one because some of you might give one of the correct answers. One possible answer, if you're thinking the answer is it's a chord, technically you're correct. A more specific answer would be that this is a diameter. Right, so this is also a diameter. So diameter is a specific chord within the circle. How do I know this is diameter? Well, this is a semicircle, so it cuts it in half. So that must mean this line is going through the center. So that must be a diameter. All right. If point P moves, does the measurement of QPR change? So QPR is this measurement here, which we said was 90 degrees. So does that measurement change if I move this point? So if I move point P to somewhere, to maybe over here, is it going to matter? So let me kind of draw this out for you, see if this helps you visualize this, see if this works. All right, so if here's this triangle that's created, right? So if I move this point, does the measurement of that angle change? Does the measurement change? So is it getting bigger? Is it getting smaller? I don't know if you notice. So see if you could think about this. Does it get bigger or smaller? Let's say I'll leave it there for now. All right, so let me prompt you there. I think this is a good question. If point P moves, right? If I move point P, let's say this is point P, does this angle change? Right? Is this angle the same as this angle, or is it a different measurement? You let me know. Does it change? Yes or no is fine on this one. All right. Well, it appears, I don't know if you got this correct, but it does not. All right, so this measurement stays the same. Why does it stay the same? Well, if you notice, even though P is moving, Q and R are not moving. And from Q to R is always going to stay 180 degrees. So this inscribed angle still has this arc of 180, which means it's still going to be 90 degrees. All right, so that movement of that angle didn't matter because Q and R stayed in the exact same spot. All right. So part D is a kind of a separate problem, but related to this topic. So it's a new diagram we're looking at. If UV is a diameter, okay, perfect, just like the other problem, then triangle UVT is a blank triangle. What kind of triangle would you call this? All right, all we know is UV is a diameter. And so what does that make this triangle? What kind of triangle is it? So I'll give you some options here. Is it an isosceles triangle? Is it an equilateral triangle? Is it a right triangle? I'll give you those three options. Isosceles, equilateral, or a right triangle. So let's see if you get this correct. All right, if you said this is a right triangle, you are correct. And how do I know it's a right triangle? Well, if we said this is diameter, then that means the semicircle, this must be 180 degrees, which means this angle must be 90 degrees. All right, so this is 90 degrees. Okay, so if TU in this picture has a measurement of 6, so from T to U, let's say this is 6 units, and let's say from T to V, let's use a different color here. T to V is going to be 8 units. Then what is the radius of this circle? Well, how does this relate to a radius? Well, if you notice, we just created a right triangle, so that means we should be able to figure out the measurement of UV. All right, so what is the measurement of UV? Now the radius is not UV. UV is half of this. So if I could figure out the whole thing, then I could figure out the radius. So then my first question to you is going to be, well, what's the diameter of this? So I'll help you set this up just so we could get this started. So we're going to use Pythagorean theorem here. This is going to be 6 squared plus 8 squared equals 2, let's say, UV squared. So I'll just use the letters UV. All right, so we want to know what UV is. Go ahead and calculate that. Let me know what is the diameter of this. So UV equals to what? All right, let's see if you got this correct. So if you calculated this correctly, you should end up with 100 equals 2 UV squared, which means UV has to equal to 10. All right, so that means this whole distance here is 10. Question now to you is, what is the radius, right? What is half of this measurement? Well, if the diameter is twice as big as the radius, then that must mean that our radius is going to be 5. All right, and so this is a huge problem. We've realized this is a right triangle. We've used Pythagorean theorem. We figured out the diameter to give us the radius. Why would we need to do all this work? To really just solve one little problem at the end, and that is, what's the area of this circle? So if you don't remember formula for area of a circle, that one's going to be, area of a circle is going to be equal to pi r squared. So my question to you is, what is the area of this circle? Leave your answer in terms of pi. If you calculate it with pi, you'd end up with a decimal. We don't want a decimal here. So I'll just work this one out with you as a reminder in case you've forgotten how to do this. So this is going to be pi times radius squared. Radius we said was 5. So that means we're going to end up with 25 pi. Units squared, right? There's no units given here, so we'll just say units squared. So this is 25 pi. All right. So that one's a huge problem. There's a lot going on there. And it's a lot of review of stuff we've gone over before. Area of a circle, Pythagorean theorem, and we've just introduced semicircle as well. So you'll notice this started off as a circle problem, but the reality is it turned into a triangle and an area problem. All right, moving on, a couple problems. Here's another common question is you'll notice we have a circle. This is a circle that has a quadrilateral inside of it. So you'll notice all 4 vertices of the quadrilateral happen to be on the circle. And if I give you one angle, in this case 100, and I ask you, well, what's this other angle right across from it? What's the measurement of that one? How would we figure that one out? All right, so I'm going to walk you through this one because definitely it's a bit challenging if you haven't seen this before. So I'm going to start with this angle. I always like to highlight the angle, makes it a lot easier to follow along. So if I have angle D, or I'm sorry, angle C, which is 100, and I focus on the arc that's associated with it. So in this case, the arc goes from B all the way to D. All right, so if I know this is an inscribed angle, 100's an inscribed angle, then what's the measurement of its arc? All right, so this is where you need to remember that relationship between this inscribed angle and its arc. All right, so I'm going to help you out with this one. So this is going to be 200 degrees. All right, so 200 degrees, you'll notice this is also happens to be from B to A to D is actually a major arc, right? Which means from B to D would be our minor arc, and together they're supposed to complete 360. So then let me ask you this, what's the measurement from B to D? How many degrees is that? All right, so let's see if you got this correct. This from the measurement, oops, let me use a different color. The measurement from of arc BD in this case is going to equal to 360 minus that 200, which is going to equal to 160 degrees. All right, so this arc here is going to equal to 160 degrees. Well, you'll notice also that this happens to be, if I focus on B and D, this happens to be the arc that connects to this angle X. So now, what's the relationship? If arc BD is 160, what does X equal to? So you tell me, what does X equal to? All right, so if you remember this, X in this case is going to equal to 80 degrees. All right, so X equals to 80 degrees, half of the 160. All right, pretty simple. You'll notice it's just a lot of going back and forth, understanding inscribed angles. Calculations were not very intense. 360 minus 200, and then 160 divided by 2. Pretty straightforward. All right. Next problem. Another key type of problem here is there's this type of problem where we have a circle and we have two chords that intersect inside, we want to know how they're related. You'll notice neither one of these is the diameter. They're both just chords. We don't know if they're the same length. They may or may not be. So what we're going to do to better understand how they're related is we're going to add segments DB and AC. So let's add let's see. So segment DB, I'll draw a line from D to B and a segment from A to C. Oops, see if that kind of fits. All right, so you should notice as we draw in these extra lines, we've actually created two triangles. And so let's compare angle B with angle C. In this case, angle B is this angle, angle B. And we're going to compare it to angle C. How are they related? Well, if you look closely, you'll notice something about the arcs. All right, so from D to A, you'll notice they both connect to D and A, and they both share this arc. All right, so what does that mean? That means these two angles are the same. That means these two angles must be the same. And you should also notice that we have vertical angles. All right, so that must mean that these two triangles that we've just drawn in must be similar triangles by, we could actually use angle-angle similarity, right? Because we have a pair of vertical angles in there as well. All right, in this case, corresponding sides are, I don't know if you remember this, but keyword here is proportional. So now this becomes this circle problem that we started with a couple of chords. You could see now it's relating back to similar triangles in our use of proportions. All right, so let's use that knowledge to solve a problem that actually has numbers in it. So same diagram, I've just added some values to some of these segments. So this is a common test question. So if I give you DE, in this case DE is equal to 8. So that means from D to E, I'll put some measurements in here. So this is 8 from D to E. And from A to E, this is going to be 4. And from E to B is going to be 6. All right, from E to B, this is going to be 6. All right, so what is the measurement of EC? So we're trying to figure out what this little measurement here is. So how do we use our prior knowledge? Well, if I draw in those extra lines, which I'll give you a hint, we're really not going to be doing this all the time, just on this problem. And so you'll notice, since these are proportional, we could set up a proportion where if we're trying to figure out what EC is, right, we're trying to figure out what EC is, which side corresponds with EC. Now it might not be obvious, but in this case, since these angles were matching and these were matching, this is kind of like a mirror image of each other. They just happen, one happens to be smaller, kind of like a butterfly with one wing is really small. So that must mean that these two sides are corresponding. So that means EC corresponds with 6, which means 4 corresponds with our 8. All right, now that's the proportion we're setting up. What happens when we cross multiply here? Well, we're going to end up with 8 times EC, and we're going to end up with 4 times 6. All right, so at this point, we would solve this and get an answer. So we would use our additional skills, maybe divide both sides by 8, and then we're going to be left with EC is equal to 3. All right, so now that measurement, we realize this measurement here is going to be 3. So overall, not too complicated, but you might be thinking, well, I don't want to have to draw in these extra lines. I don't remember proportions. This is confusing. I don't want to remember similar triangles. Well, then let's find a faster way. And let me show you how to do this a bit faster. So a couple things to note was when we look closely at this part here, you'll notice everything here is taken from the picture. So we have 8, we have an 8. We have EC, which is this measurement here, and we have 4 and 6. So 4 and 6. So you'll notice 4 and 6 are on the same line, and 8 and EC are on the same line, which means maybe we could skip this whole proportion, and maybe we could have just gone straight to this part where it's already cross multiplied. So if it's on the same line, then we just multiply them. So this leads to our formula. So if we have, here's a formula that you need to know. So in this case, I've labeled them each parts. So this one chord has parts A and B, and if I multiply those, A times B, that should equal to the other chord, C times D, because they're on the same line. So A, B, C, D. Just remember them in that order. A, B is on the same line, C, D is on the same line. And here is a nice little formula we could use to calculate any of the missing pieces. So if I give you, again, those numbers, right? If I give you, if this is 8 and this is, what was this, 4 and this is 6, and I want to figure out maybe what this is, I'll just call it X. Shortcut is, if it's on the same line, right? If it's on the same line, then we multiply it. So in this case, we have 8 and X are in the same line. So I would do 8 times X, and 6 and 4, 6 and 4, right? And that's it. And then it's ready to solve. You can multiply and divide, and you'll end up with X equals to 3. All right, so that's a general idea of how to do that problem, common test question. And let's see, almost done. All right, and then here we have how long is the chord. So if I want to actually know how long this chord is, and the only piece of information we're given is the radius of a circle, which is not drawn in here. So radius, we could put it anywhere we want. Most likely we're going to draw it to this segment. And we know the measurement of arc LM is equal to 150. So I know this is 150. And I know there's a radius. So I'm just going to draw in a radius for us. So this is 6 units. I want to know what the measurement of LM is. How would we figure that out? Well, the nice part is if I actually draw, if I cut this in half, right? If I cut this in half, then what we do know is a measurement of an angle. So that must mean that then this angle is half of 150, which is 75, which means this is a 75-degree angle there. And I've created this right triangle. Where I could actually find missing measurements. So I could figure out what the measurement is half of that chord. So if I have an angle and I want to find this side that's opposite it, but I have its hypotenuse, then this is a perfect time for us to use our trig ratios. So this is going to be sine of 75 degrees is equal to, I'll use x, we'll call this x here, this line here, over 6. Which means x is going to equal to 6 times sine of 75, but we want to know the length of the chord, and for us, the chord is LM. So in this case, I could say LM is going to equal to 2 times 6 times sine of 75, which is going to equal to 12 times sine of 75. This would be an exact answer, which could be okay on a test. You have to double check if they want a decimal or not. If we want an approximated answer, then we would have to type that into the calculator. So I'll hold off on that for now, just to kind of speed things up. And then here are some additional problems for you. I won't work these out with you, but if you want solutions to these, you want to double check your work, let me know, send me a message so that I could help you verify your answers on these. So these would be the last 3 questions for you to test out all the stuff we've covered. This should look familiar to you. This is similar to the one we did earlier. Q is not in the center, so don't think Q is in the center. So this is not, neither one of these chords is the diameter, just to let you know. And then this is the center of the circle. And this markings means all these pieces are the same size. This one might be a little bit tricky. I'll give you a hint on this one. There's a triangle here, and it's a 30, 60, 90 triangle. See if you could figure out which one's which on that one. And then try to figure out, if you have the inscribed angle, figure out this arc, and if you do, then you should know a big major portion of the circle to help you figure out this minor portion. All right, let me know if you have any questions, and we'll see you next time.